Hello, students, and welcome to part 3 of current resistance and electromotive force. So this is still under the LEP number 5 with the same title. For parts 1 and 2, we've already discussed current, resistivity, and resistance, as well as Ohm's law. And today, we're just going to discuss energy and power in electric circuits, because we know naman that's the main purpose of our circuits, to convert whatever kind of energy it is into electrical energy. And in the process, since energy is dissipated or energy has been used, power is present, no? Ayan, so let's discuss the difference between EMF and PD. EMF stands for electromotive force, and PD stands for the potential difference. Let's start with EMF. EMF ensures the continuous supply of electron flow in a circuit. It is also defined as the work done by a source in driving a unit charge around a complete circuit. Notice that when we studied potential difference, it is defined also as work done. It's work done on a unit charge to uh, to transport that charge from a place of lower potential to a place of higher potential. So they are similar in the sense of both of them are work done, and they are being done on a unit charge. Okay? So, ang pinagkaiba nila, unang-una, is that for potential difference, it's always from the lower to the higher potential. But here naman, it's going to be around a complete circle. There are actually two types of EMF sources. One that converts chemical energy into electrical energy, such as batteries and dry cell. Ayan, chemical energy yon, di ba? Stored energy particularly. And then another that converts mechanical energy into electrical energy, such as generators. Generators actually are the major sources of the electrical energy that we have at home. Such yung mga generator na yon, pwedeng dahil sa dam, no, yung mechanical energy due to the movement caused by dams, yung mga water doon, o kaya waterfalls, yun yung nagagamit for generators, and then some of it are delivered to us as electricity already, no? Tapos sa mga maliliit na bagay naman, we have the batteries and the tri-cell, such as remote control, ganyan, okay? The symbol for the EMF is this one, the Greek letter epsilon. Ayan. And so yun yung pinagkaiba nila, no? Pareho silang work done, pero yung potential difference from higher to lower potential, while EMF is for the complete circuit. Another difference is the symbol. For the potential difference, we have delta V initially, and eventually, we're just calling it voltage or capital letter V. And then the symbol naman for EMF is this letter. This is Greek letter epsilon. Now, another similarity of them is that they have the same standard unit, which is volts, and then they are both also scalar quantities. So in a circuit, the potential difference actually is the voltage in the circuit load. Yan. Dito. So yan yung V natin. That's the voltage across the circuit load. On the other hand, the EMF, ito, is the voltage across the power source or the dry cell. Siya yung mismong, anong tawag doon, rating ng ating dry cell. Now, bakit pa sila pinagkaiba? Hindi ba kapag kung ano man yung voltage nitong ating battery, yun din yung magiging voltage dito sa resistor? Kasi isa lang naman yung resistor natin, so dapat pareho lang sila. Now, this battery kasi, because of its components, still has resistance in it. So, sa ideal version or sa ideal circuit, ito kasi considered as real circuit na talaga siya or in real life. In ideal circuit, the battery is considered to have no resistance. Ang may resistance lang ay yung mismong resistor or yung circuit load. Now, if we account the resistance of the power source itself or the dry cell itself, kasi alam naman natin sa loob nun may materials, pwedeng may metals, usually zinc and stuff like that. Meron din yung resistance, no? Hindi lang yung ating resistor. Although sobrang liit lang nito, sometimes it can make the difference. How, no? Minsan, manonotice nyo to, i-measure nyo yung voltage ng battery, tapos magiging iba siya dun sa voltage ng mismong resistor natin. And again, that's because the battery itself already has its own resistance, although napakaliit lang niya. No? So, originally, if the circuit is ideal, the current is equal to V over R, equal to the quotient of the potential difference and the resistance of this. Okay, resistance of the resistor. Now, if the circuit is not ideal, the current will now be equal to the electromotive force divided by Ri plus Re. So Ri is the resistance of the battery or the dry cell, and then Re is the resistance of the circuit load or the resistance. Resistor pala, okay? So let's define each variable. Again, the I is the electric current in ampere. The epsilon is the electromotive force. Although its name is electromotive force, it's not a force, no? Please take note of that, okay? That's why hindi Newton yung kanyang standard unit, kundi volt. Again, pareho lang sila halos ng potential difference. However, they have different purposes and they act in see EMF, it acts in a specific situation such as the circuit potential difference. Kahit hindi nasa circuit yung charges natin, nandun siya, okay? And then we have the R sub I, which is the internal resistance or the resistance of the battery or cell itself. And the standard unit for that is still ohm. And then the Re is the external resistance, which is the resistance outside the battery. Kaya siya external. Tapos yung internal, nasa loob ng battery. So the external resistance can be provided by a resistor or any circuit load such as bulbs. Okay? So from the equation here, we have to derive the equation for the electromotive force. So step number 1 is to cross multiply. Kaya naging ganito na siya. Naging I times Ri plus Re is equal to epsilon. Now, if we distribute the I, ayan, it would look like this. I, R sub I plus I, R sub E is equal to is equal to EFF or the epsilon. And notice that the I times RE became V. Bakit ganon? Kasi di ba kanina, I told you, balikan natin yung previous slide. Una-una pa, ayan. I told you that this R is actually the voltage of the R. The R is actually the resistance of the resistor. It's the same as the external resistance. Kasi nga, kapag hindi natin consider yung resistance ng battery natin, ito lang yung i-consider natin na resistance. So, ganito lang siya kasimple. Nagiging complicated lang when we already considered the resistance of the battery itself. Okay? Kaya dito, yung when we multiply the I and RE, alam naman natin galing yun sa B, is equal to IR. Ayan. Pwede natin siyang i-transform into B. Okay? Ayan. So, pwedeng gamitin natin yung mga equation na nandito para sa electromotive force or pwedeng ito yung gamitin natin. No? Mamimili lang tayo depende sa given. So again, the I is the electric current in ampere, the epsilon is the electromotive force in volt, and then R sub I is the internal resistance of the battery or cell in ohms, and then V is the terminal potential difference or TPD. So para further ma-differentiate pa natin si electromotive force at si potential difference, sometimes in some references, the V is also called terminal potential difference. So bakit terminal? Dahil nandun siya sa yun yung voltage across the two terminals of our resistor. Okay? Pareho lang yung potential difference tsaka TPD ha. Magkaiba lang dito electromotive force tsaka yung terminal potential difference. Ayan. So I hope that's malinaw. Let's have sample problem number 1. A storage battery of internal resistance of 0.4 ohms is to be charged from a DC line. If the EMF of the battery is 12 volts, what resistance must be placed in series with the battery to limit the charging current to a safe value of 4 ampere? And what is the TPD? So, dalawa yung nawawala. Let's first enumerate the given. We have the RI. Ayan naman, sinabi agad-agad dito na internal resistance siya. It's 0.4 ohms. And then, sinabi din agad-agad yung EMF. That is 12 volts. And then, we have the I or the current, which is 4 ampere. Okay? And for the required, we are looking for the external resistance. Paano nasabi na external resistance? Hindi naman explicitly sinabi na what is the external resistance. But the question here is, what resistance must be placed in series with the battery? Therefore, it is outside the battery. It's a resistance outside the battery. Therefore, it is the same as the external resistance. And then the next question is, what is the TPD or the terminal potential difference represented by capital letter V? The equations we're going to use are RE, R sub B is equal to E over I minus RI, and then for the B, TPD is equal to E minus I R sub I. Let's derive the first equation. Ay, wala pala, hindi ko pala tinype. No, sorry, nakalimutan ko. Okay, so saan to galing siya? Siyempre galing siya doon sa E is equal to I times Ri plus Re. Ayan. So step number 1, we divide both sides by I so that we could cancel the I kasi we consider as one term yung Ri saka Re. Okay? Ayan. Di na natin kailangan i-distribute kasi mas magiging complicated siya. So na-cancel na natin. So we are going to have Ri plus, pagbabalik na rin lang natin, no, para mas ma-isolate natin yung Re, is equal to epsilon over I. Now, to fully isolate Re, we have to transpose Ri to the other side. And since it is positive in this side, it will become negative on the other side. So we will have R sub E is equal to epsilon over I minus R sub I. Okay? Ayan. So, para naman ma-derive naman yung letter B, madali lang siya. Galing lang siya dun sa E is equal to I, tama ba ako? Tama. IRI plus B. Okay? So, nangyari naman, so that we could get the B, we transpose to the other side, the IRI. That's why the IRI becomes negative. Okay? Ayun. Dito lang siya galing sa letter B. Now let's proceed to the solution. We just have to substitute everything and we get, excuse me, 2.6 ohms for the external resistance. Notice, no, ang laki medyo malaki yung diferensya ng internal saka ng external. Tapos sa solution 2, we substitute again and we get the 10.4 voltage or the TPE. And notice, yun nga, there are times, syempre yung EMF or electromotive force, the voltage of the battery, is always larger than the electromotive, the terminal potential difference of the resistor. Okay? Ayan. Laging mas malaki yung voltage ng battery. Hindi lalampas dun dapat yung ating TP. Sample problem number 2, a storage battery has an EMF of 30 volts and an internal resistance of 0.25 ohms. What is the terminal voltage? What is its terminal voltage when it is A, delivering a current of 8 ampere, and B, when it is delivering a current of 8 milliampere? So we have the RI, sinabi naman dito internal resistance, tapos sinabi rin na EMF, so 30 volts, and then we have two scenarios, the scenario A and scenario B, hence the subscripts of the current. We have the current for the first scenario, and that's 8 ampere, and then we have the current for the second scenario, which is 8 times 10 raised to negative 3 ampere. Don't forget, nasa given pala, magko-convert na tayo, no? And we know naman that milli is equivalent to times 10 raised to negative 3, and then it's ampere. For the required, we're looking for the voltage for scenario A and then the voltage for scenario B. Or in short, we're looking for the terminal potential difference when the current is 8 ampere, and then another one, we're looking for the terminal potential difference when the current is 8 times 10 raised to negative 3 ampere. We're going to use the same equation. It's just that for VA, we're going to use IA, and then for VB, we're going to use IB. This is also the same equation we used for sample problem number 2 in solving the terminal potential difference. So let's substitute the given, and we get 28 volts for the VA. And then for VB, we substitute and we get 29.998, so almost 30 volts. Okay, ayan. So now let's proceed to the equations for solving energy and power of a circuit. Notice that in solving for the energy, instead of work over work over, tuloy pareho palang work yun. Instead of the usual equations that we've learned in the past lessons, dito, naka-express siya in terms of voltage, in terms of charge, in terms of current, and in terms of resistance. Kasi nga, ang pinag-uusapan na natin dito is not mechanical energy. It's not even uh, chemical energy, but specifically it's electrical energy. That's why we have to express our equations for energy and power in terms of the quantities related in constructing circuits. Okay, so for energy, we have 1, 2, 3, 4. We have 4 equations. First, in terms of voltage and charge, and then we have in terms of voltage, we know that Q is I times T. Sinubstitute lang siya dito, kaya naging V is equal to IV. E is equal to V times IT. And then we also have I squared times RT. And then we have this. Basta ayan, lahat sila. No? Depende sa kung anong given, saka ka mamimili kung ano yung gagamitin mo dyan sa kanila. Okay? Ayan. So kung babalikan mo to, baka kasi sabihin niyo ang bilis ng sinabi ko, no? Familiar naman tayo sa letter P. P is power. E is energy. Yung V, ang tagal na natin pinag-uusapan yun. Potential difference, di ba? Hindi na yan electromotive force, ha? Yung maarting letter E, yung parang baliktad na 3, yun yung electromotive force. Ito, energy talaga to, no? Electrical energy in particular. Tapos yung power, it's electrical power naman, no? And then yung I, current pa rin siya. Yung R is still resistance. And the lowercase letter T is also still time. So let's apply some of these equations into sample problems. We have sample problem number 1. It says here, assuming total conversion of electrical energy to thermal energy, how much thermal energy is produced by a 20-watt heating unit in 6 seconds? Take note, if the W is together with the number, it is the unit for power, watt, W-A, double T, and it does not mean work. Baka kasi isipin nyo, produced by a 20 work heating, hindi ganon, ha? Okay, the W here stands for watt. It's a unit, it's not a quantity, okay? So let's write the given. We have power, 20 watts, and time 6 seconds. We are looking for the energy, and energy is just the product of power and time. Ayan. So, substitute lang natin and we get 120 joules. Okay. So, bakit sinabi ito assuming total conversion? Because it's not always that all the electrical energy is converted into the purpose of the appliances. For example, ito kasi heater to, no? So, yung ibang, hindi lahat ng electrical energy ay nagagamit so that the heating unit will heat up the place kasi uso to sa ibang bansa, no? Kailangan nila ng heater. Sa atin, kailangan natin ng air conditioner naman on the other hand. So, hindi lahat yon ay nagagamit para painitin yung room. Some of it are wasted tapos napupunta siya outside the room. Hindi 100%, hindi total conversion. Okay? So, ganun sa halos, hindi, ganun sa lahat ng totoong circuit. Hindi lahat ng input mo na energy, yun din yung output na energy. Laging may nasasayang. Okay? Ayan. And then let's proceed to sample problem number 2. A burning lamp is spark 20 watts, 120 volts. Okay? So, hindi kasi ako sure kung tinitingnan niyo yung mga appliances nyo, no? Usually naka-indicate doon ano yung wattage, tapos ano din yung voltage, no? Ayan. So, how much current flows through the lamp? Notice 120 to. So, hindi to pwede sa Pilipinas, no? Kailangan mo nito ng transformer. Kasi usually 220 kapag sa Pilipinas. Okay? How much current flows through the lamp? And then letter B, what is the resistance? So, we have P is equal to 20 watts and V is equal to 120 volts. We are looking for the current as well as the resistance of the burning lamp. Excuse me. For the current, we have I is equal to P over V. This one, wait lang. Titignan ko kung naisulat ko na hindi pala naisulat. So, ako magsusulat. Ayan. So, the I is equal to PV came from, kung babalikan natin yung listahan ng mga equation natin for power and energy, it's P times IV. So that we could get an equation for current with factors power and voltage. Ito yung pipiliin natin and just divide both sides by V. Makakancel na yung V. And ito yung kalalabasan niya. Okay? And again, dun sa mga equations natin, we have to look for an equation wherein we can find the resistance, the voltage, and the power. Why? Because we're looking for the resistance and the given are the voltage and the power. So, hindi naman pwedeng gumamit ka ng current. Although, masusolve mo siya sa letter A, mas maganda kung hindi mo na kailangan kumuha from previous computation para lang masolve mo siya. So, ito yung pinaka-ideal na kukunin natin. Ito galing naman siya doon sa equation na P is equal to V squared over R. Ayan. We just cross multiply, or para mas madali, we just have to multiply both sides by R. Yun muna. Sige, para ma-cancel yung R dito. Ayan. So, magiging RP na siya is equal to V squared And then we divide both sides by power so that we could fully isolate resistance. That's why we have R is equal to V squared over P. And then we're going to substitute for the letter A. And then the answer would be current is 0.17 ampere. And then the solution for number 2, again, we substitute and we get 720 ohms. Okay? Ayun lang. Thank you for listening. And for next week, we're going to discuss naman direct current circuit. So ito na naman yung katulad ng sa capacitors in circuit na meron tayong circuit analysis, tapos hahanapin natin yung individual voltages and individual currents naman. Okay? Para dun sa ating direct current circuit. Yun lang. Thank you for listening again and see you next week.